Right, here comes your sea otter question. Lovely question 7 here. It describes a lovely scenario to you with sea otters feeding on urchins, crab, and shellfish. Gives you a lovely picture to give you an idea as to what they're looking like. So here's your otter and the urchins, very spiky things on them. It also gives you a lovely picture of the biodiversity, so a kelp forest on one side, and here those sea urchins having munched away most of that kelp forest. Okay. Your first question isn't actually on the scenario much yet. It's literally a definition of climax community. So part 1, 2 marks, explain what is meant by a climax community. That last stage of succession, when you're going through all your pioneers and then you got, what was it, pioneers, and then your various stages, your serial stages in succession. Your climax community is your last one, a stable, long-term, maximum biodiversity climax community. That's the first bit. And the second bit here, why regrowth of a kelp forest is an example of secondary succession. I made much of a point of soil availability. Now, in this context, that is not obvious. The answer you're looking for here is that you have already had an area that has been populated before. Primary succession would be bare rock or sand with no species ever having lived there before. So secondary, an area that has already been populated, been there before. So you've got your marks game, final stage of succession for the first bit, and the area that has been previously colonized before. Good. It then moves you on to another question here. In addition to sea urchins, sea otters also eat crab and shellfish. That is a bit of a repeat. If you see a repeat, a bit like the wording temperature on the other paper, if you see a repeat, it kind of, why do they repeat that? Why do they stress this? So bear that in mind. Using your knowledge of predator-prey relationships, bolded up. So predator-prey relationships, those what happens in a food web needs to be discussed here. Suggest how the presence of sea otters in a habitat maintains biodiversity. The first thing that has to click in, the sea otters, if they're there, they are eating the urchins, which means the urchins do not get to eat up the entire kelp, the entire plant. Primary producers would then still be there. That means you'd have primary producers there, which the crabs can eat, or whatever else, whatever stages in between there might be on that, in that food web. So you've got food available for the crabs and for the shellfish. So in that context, that's how it maintains biodiversity. However, you also need to comment on the predator-prey relationship situation. This question is not saying that you need to discuss interdependence, but that is exactly what you need to do. So if sea otter numbers go down, sea urchin numbers will go up. Therefore, the destruction of the sea kelp and so on. However, if sea otter numbers, if we have the feeding relationships in a different context, if now the kelp is lower, there will be fewer crabs, so the other prey species will be there. That means the predator, the sea otter, will not have its food availability. If, however, sea otter numbers are high, what will they eat? They've got a choice of all three, don't they? They've got a choice of urchin, crabs, and shellfish. That's a nice wide variety. So let's play through the thought process. Let's say the sea urchins are overpopulating and you get suddenly 200 sea urchins and only 5 crabs and 2 shellfish. What will the otters eat? Of course, they're going to eat the prey species where they are most off. They won't be on purpose hunting out the last 2 remaining crabs. So sea otters are therefore stabilizing the whole food web by going for whatever you're going to have most of in terms of the prey part of that food web. So the mark scheme expresses it like this. Sea otters eat the sea urchin, which keeps the forest to regrow. A wide range of niches is a wide range of food habit. Okay, I would have forgotten that one here. The wide range of niches being developed through that. Because sea otters eat a range of food, no single species gets to dominate. So the overgrowth of sea urchins would not have been possible through that. It's a density dependent thing. As density of population of prey increases, the predator will have more food. As a result, the prey population decreases, and the predator will go for a different species. So that's how it's expressed in the mark scheme there. Whichever way round you have managed to fit these arguments into your answer. Okay. What is the next one here? Okay. Explain why scientists consider that the destruction of sea otter populations could contribute to an increase in global warming. Okay. This question is literally hunting you for you to say all the words that it didn't say. It used global warming, but it did not say the name of the gas. That's a global warming related greenhouse gas. It did not say that kelp do photosynthesis, because you are meant to do that. You are meant to kind of connect those dots. So if fewer sea otters, that means higher number of urchins. The number of urchins will then eat up the kelp. Less kelp means less photosynthesis will take place. Less photosynthesis means less carbon dioxide is removed from the oceans, which means less carbon dioxide in the oceans means more carbon dioxide needs to dissolve in the oceans, which means you're going to lower the carbon dioxide in the atmosphere, so the whole environment gets affected by that. Plus, stating that carbon dioxide is a greenhouse gas. So literally a question of say the things I'm not saying in that question. So as the sea otter number declines, the urchins are not eaten, so less kelp, therefore less photosynthesis, less carbon dioxide removed. Okay, you can go straight to the environment. You don't need to go via oceans and the atmosphere, so that's lovely. And carbon dioxide is a greenhouse gas. Then we have got the next one coming. What was the next one? Explain why an increase in global warming could have been a contributory factor in the planetary boundary for biodiversity being crossed. What was your boundary for biodiversity? So species diversity. This question, literally, if you try to rephrase it, how does global warming kill off species, or is a factor in the extinction of species? That needs you to use the word temperature somewhere. It kind of it's obvious. If the planet's warming up, the planet's warming up and the temperatures increase, what effect does that have? Some species may not cope with the high temperatures as such. Some species may not cope with what those high temperatures will have a follow-on change in weather and climate patterns, rains, droughts, storms, glaciers retreating. Everything as a secondary effect of that temperature change will change habitats. If the habitats are changing quicker, then the actual species can migrate to a different habitat that might then have become more suitable, or then the species can adapt, evolve and cope with those new conditions. At that point, these species go extinct. So let's see what the mark scheme as such actually wanted from you. Right. Temperatures increase above an area what is suitable for the organism. All right, that is already it. Okay, I've gone a bit further than that. The mark scheme is giving you marks quite quickly here. So temperatures increase faster than the organism can adapt, causing destruction of the habitat, as long as you have got a complete factor and an explanation. As long as you get that combination right, you get the 2 marks. Good, and then you have got your your fur question. That was a sweet one, but a little bit like, we need to make sure we ticked the maths boxes. You've got your numbers, and this is, can you handle the to the power of situation? That is assessing your mathematical ability to deal with larger numbers. Or indeed, you might get one with to the power of minus something numbers too. Do a similar calculation, okay? These ones are still within the range of you being able to actually write out all your zeros in case you needed to go down that route. Give your answers in standard form as well. So what was your actual question? Calculate the number of hairs per centimeter square, and you've got the number of hairs in total, and you've got the number of surface area in total. So it's literally your 8.64 times 10 to the power of 8 divided by your 7.2 times 10 to the power of 3. Just making sure you don't mess up your big mass and you don't mess up your numbers with that whole thing. You should have gotten, I'm just looking at it, should be 10 to the power of 5. Yeah, that looks right. Okay, I can accept 1 mark if you had written it down and then didn't bother changing it back into your standard form. Yeah, that's correct. That's the right number of zeros. Here we go. Here we go. This one here. What is this? Suggest the homeostatic role of the high density of hair in sea otters. hair blubber layers, whatever it is you're going to have on an organism like that, that's the insulation role. That is insulation. It traps a layer of air usually in a fur coating. It's usually sealed with oil as well, so that no water seeps in between those hairs. So you've got a lovely air layer. Particles are far away from each other in air, so conduction is reduced a lot. Yeah, so insulation is that key word. Maintaining a constant internal body temperature, as it is a mammal, is covered in fur and feeding young on milk. The last question of that lot. In recent years, the numbers of sea otters has increased as a result of many different conservation methods. Describe 2 conservation methods which may have aided the recovery of the population. I want to go back a little bit and read one line out that was given to you earlier here. Sea otters were hunted by humans. As much as you may want to do breeding programs, which is great, breeding programs are good, but as long as you're not removing the hunting, you're going to kind of fight a losing battle and kind of try to roll something up the pyramid. So what could be happening here? Some sort of legislative thing that is stopping that hunting or limiting the hunting, or yeah, something along those lines, that you have got that factor removed. And the other one is a little bit up to you what breeding programs you could have there. So fur trade restrictions, legislation of hunting, protecting areas, breeding programs. So a range of things would have gotten you that mark there. That was question 7.